There is something happening right now that you haven't named yet. Not a thought, not quite a feeling. Something lower than both. A faint reorganization in the chest, a shift in the way the air moves through you. The kind of thing you'd miss entirely if you weren't already very still. It isn't pain. It's more like the body quietly clearing the table for something that is on its way. This is where grief begins. Not in the mind, not in language. In the body. Hours, sometimes days, before the conscious self catches up. The immune system moves first. That's the strange part. Before you've processed what happened, before you've said it out loud or heard it from someone else or sat with it in a room alone, certain immune cells have already shifted direction. Pro-inflammatory cytokines, proteins your body uses to signal internal threat, begin to rise. Not dramatically, not in a way you'd feel as fever or swelling, just a quiet uptick. A change in chemical tone, the body registering something the mind is still holding at a distance. Researchers who study bereavement have measured this. In people who have just experienced significant loss, inflammatory markers move within the first 24 to 48 hours. The body does not wait for grief to be understood. It responds to the signal of disruption, whatever form that disruption takes. It doesn't distinguish. A wound from a fall and a wound from loss arrive at the cellular level, wearing something like the same face. Somewhere behind the sternum, the pressure is already there. You may have felt it. That heaviness that sits just under the collarbone, not quite ache, not quite weight, but something between the two that doesn't move when you breathe around it. Part of what generates that sensation is the vagus nerve, which runs from the brainstem down through the chest and into the abdomen, touching the heart, the lungs, the gut. It is one of the longest nerves in the body, and it is exquisitely sensitive to states of social and emotional threat. When the vagus nerve shifts into a protective mode, what some researchers loosely describe as a withdrawal state, the muscles around the throat can tighten almost imperceptibly. Breathing becomes shallower without your choosing it. The heart rate variability, normally a kind of gentle rhythmic flexibility in the beat, flattens slightly. The body is bracing, not against a physical blow, against a change in the world that it has somehow already registered. The hum of something electrical, maybe a refrigerator, maybe a neighbour's television, carries through a wall, and still your chest doesn't move the way it usually does. What the hypothalamic pituitary adrenal axis does in these first hours is not a surge. People often imagine cortisol spiking like a wave, dramatic, sudden, visible. But in the early hours of grief, it tends to be subtler than that. A slow lift, a raised baseline. The kind of cortisol elevation that doesn't feel like stress so much as a low-level hum of something alert underneath ordinary experience. You can hold a conversation, you can make tea, you can answer someone's question and answer it correctly, and still the cortisol is slightly higher than it was this morning. The adrenal glands don't know that what they're responding to is a loss. They know only that the brain has flagged a disruption of significant magnitude, and they've responded accordingly, adjusting the body's internal chemistry in the direction of sustained alertness, sustained readiness, a kind of metabolic posture that says, something has changed, and we are not yet sure what comes next. It's exhausting in a way that doesn't feel like exhaustion. It feels like being awake inside a very quiet room. There's a part of this that still isn't fully understood. Why the body responds to emotional loss with the same biochemical toolkit it uses for physical threat. That question has been examined from many angles, and the answer most researchers arrive at has something to do with evolution. For most of human history, separation from a group or attachment figure was genuinely dangerous, physically dangerous. The immune response and the cortisol rise, the vagal withdrawal, these weren't overreactions. They were preparation. They were the body getting ready for a period of exposure and vulnerability, that separation historically almost always meant. The body still runs that same protocol. It doesn't know that the danger is different now. It only knows that something essential has changed, and it begins preparing in the only language it has: chemistry, pressure, a faint tightening in places you didn't know you were holding. You probably noticed something before you had words for it. Most people do when they try to trace grief back to its actual beginning. There's often a moment, sometimes hours before the full understanding arrived, where something felt off. A strange stillness, an odd reluctance in the limbs, a quality of attention that kept sliding away from whatever was in front of them. That wasn't imagination. That was the body already working. The anterior cingulate cortex, a region involved in both physical pain processing and what might loosely be called social pain, is active early. It receives signals. It generates a response before the prefrontal cortex, the part of the brain that narrates and explains and makes sense of things, has assembled its version of events. There is in this sense a you that knows before you know, a biological self that receives the information first and begins its adjustments quietly, without permission, without announcement. The mind will catch up. It always does eventually. But the body was already here, already changed, already moving through the first hours of something it recognized before you did. And what it recognized wasn't danger exactly, it was absence. A specific kind of absence, the kind that registers not as emptiness but as wrongness, as a shape that is supposed to be filled and isn't. The nervous system had calibrated itself over time to the presence of something, a person, a pattern, a particular weight in the world that had always been there. And now the calibration is still running, still expecting, still sending signals into a space that no longer returns them the way it used to. This is where the chapter ends, not because the biology has paused, but because the body is only just beginning. The immune shift is underway. The cortisol is moving. The vagus nerve is holding something in the chest that doesn't have a name yet. Somewhere in your cells, the adjustment has already started. You won't feel most of it. That's not a flaw. That's just how the body carries things. Quietly, below the level of language, in the hours before the mind is ready to know what it already knows. The autonomic nervous system was not built for this. That's worth sitting with for a moment, not as a criticism, not as a design flaw to mourn, but just as a fact that makes a certain kind of sense once you see it. This system, which governs your heart rate and your breath and the slow muscular contractions moving things through your gut right now, was shaped across hundreds of millions of years of evolutionary pressure. It learned to respond to cold water, to sudden movement at the edge of vision, to the sound of something large and close. It learned to survive in a physical world, with physical threats, that had physical solutions: run, freeze, fight, return to stillness. It was never given instructions for what to do when the threat has no body. When the danger is an absence. When the thing that has changed cannot be outrun or located or resolved by any action the limbs are capable of taking. And so it does what any system does when it receives a signal it recognizes but cannot correctly categorize. It responds anyway, with everything it has. The sympathetic branch activates first. Not explosively, this isn't the sharp animal panic of a near accident or a sudden loud noise. It's more of a slow pressurization, a gradual tipping of the body's internal chemistry toward readiness. Norepinephrine begins moving through the system. The heart rate climbs by a few beats per minute, sometimes more. The blood vessels near the skin constrict slightly, redirecting circulation toward the large muscle groups, legs, arms, the core, as if the body is preparing for movement that will never be asked of it. The pupils dilate a fraction. Digestion slows. Saliva production decreases, which is why the mouth goes dry in the minutes after receiving terrible news, a detail so specific and so human that it's strange nobody talks about it more. All of this happens before any decision is made, before any word is spoken. The sympathetic nervous system has already voted, already cast its assessment of the situation, already begun reorganizing the body's resources around a threat response that has nowhere useful to go. There is something almost unbearable about that, if you let yourself think about it too long. The body working that hard, preparing that thoroughly, for a crisis it cannot resolve through any of the mechanisms it was designed to use. I find that, and I'm aware this is just a personal leaning, one of the more quietly devastating things about the biology of grief, not that it hurts, but that it tries so completely, that every ancient system fires correctly, responds appropriately to the magnitude of the signal, does exactly what it evolved to do, and still none of it helps. The vagus nerve is the longest cranial nerve in the body. It originates in the brainstem, winds down through the neck alongside the carotid artery, branches into the chest where it touches both the heart and the lungs, then continues into the abdomen, reaching the stomach, the intestines, organs that seem on the surface entirely unrelated to anything emotional. It carries information in both directions, from the brain downward and from the body's organs back up to the brain, and it is responsible in large part for what researchers call the parasympathetic brake, the body's capacity to slow itself down after activation, to return the heart rate toward calm, to signal that the threat has passed and the expensive emergency response can be stood down. In grief, that brake becomes unreliable, not broken exactly, more like intermittent. The parasympathetic system tries to engage. There are moments of genuine settling, minutes where the breath deepens and the chest loosens, and it seems briefly as if the body might return to something like its ordinary baseline. And then the signal arrives again, a thought, a smell, a specific quality of afternoon light through our window, and the sympathetic branch reasserts itself, and the whole slow oscillation begins again. This is why grief is exhausting in a way that sleep doesn't fully fix. The nervous system is cycling, not resting, not sustaining crisis, cycling between activation and attempted recovery over and over, consuming energy at a rate the body can feel, but the mind often can't account for. Somewhere in a room something is ticking, a clock or a pipe or the specific sound a house makes when the temperature drops outside, and the body keeps cycling regardless, indifferent to the hour, indifferent to whether anyone is watching. The polyvagal theory, developed by Stephen Porges, offers one way of thinking about what happens next. According to this framework, the autonomic nervous system operates across three broad states, each associated with a different evolutionary layer of the nervous system. The ventral vagal state, the newest, most socially oriented, governs the sense of safety, connection, the capacity to read faces and voices and feel genuinely at ease in the presence of others. The sympathetic state sits beneath that, older, faster, mobilized for threat. And beneath both of those, older still, is the dorsal vagal state, a kind of shutdown, a biological withdrawal that the body falls into when threat is perceived as inescapable or overwhelming. In grief, especially early grief, the system moves between these states without predictability. A conversation with someone kind can briefly restore ventral vagal tone, the sense of safety, the loosening in the throat and face and chest. Then something shifts, some small reminder, and the sympathetic branch engages again, and the body loses the thread of safety it had just briefly found. This is not weakness. This is not a failure of coping or resilience or character. It is an ancient nervous system encountering a category of loss it was never specifically equipped for, doing its best with a toolkit that was built for a different kind of world. The heart feels it most directly. Heart rate variability, The small natural fluctuation in time between heartbeats is considered one of the more sensitive indicators of autonomic nervous system function. High variability generally reflects a flexible, well-regulated system, one that can respond to demands and return to baseline with relative ease. Low variability suggests a system that is either chronically activated or chronically withdrawn, spending its resources on maintenance rather than adaptation. In the days and weeks following the significant loss, heart rate variability tends to decrease. The heart keeps beating correctly, reliably, without interruption, but the subtle rhythm within that beating changes. It becomes more rigid, less responsive. The body's internal flexibility, its capacity to absorb small fluctuations and recover quickly, narrows. You wouldn't feel this. There is no sensation that corresponds directly to a change in heart rate variability. But it is happening right now, perhaps, in someone somewhere who is in the early weeks of grief, lying very still, whose heart is working harder than it looks from the outside. What the autonomic nervous system cannot do, and this is the part that matters, quietly, is receive an explanation. You cannot tell it that the threat is not physical. You cannot explain to the sympathetic branch that there is nothing to run from, no action that would help, no resolution available through the body's physical resources. It does not have a mechanism for receiving that kind of information. It responds to signals, not to narratives. And the signal it has received, the disruption of a primary attachment, the disappearance of something the nervous system had organized itself around, is as loud and as real as any signal it knows how to read. So it keeps responding. Day after day, in the early weeks especially, the autonomic nervous system keeps treating grief as an active emergency, keeps preparing the body for a response that never comes, keeps cycling between activation and attempted rest, spending resources, adjusting hormones, narrowing heart rate variability, drying the mouth, tightening the chest. It is not confused, it is not malfunctioning. It is doing, with complete biological faithfulness, exactly what it was built to do, responding to a real disruption with every tool it was ever given. The fact that none of those tools quite fit the shape of this particular loss is not something it can know. That knowledge belongs to the part of you that is still, even now, trying to find language for something the body understood first. Nothing dramatic is happening. That's the first thing to understand, or maybe not understand, just hold loosely, about what grief does at the cellular level. There is no visible event, no alarm, no single moment where a cell receives the news and changes course. It happens the way most biological change happens, which is slowly, below any threshold of feeling, in increments so small that by the time they accumulate into something measurable, days have already passed. The cell doesn't know what happened. That's worth repeating quietly. The cell doesn't know. What it receives is a signal. Specifically, in the early days of significant loss, it receives a shift in the chemical environment surrounding it. Cortisol levels have changed. Certain inflammatory proteins are present in higher concentrations than they were last week. The autonomic nervous system has been running in a state of low-level activation, and that activation has downstream effects that reach all the way to individual cells, to the behavior of proteins, to which genes are being read and which are sitting quietly in the dark. This is called gene expression. Not mutation, nothing in the DNA itself changes, but the instructions being actively read from that DNA, the proteins being assembled, the biological functions being prioritized, these shift, slowly, in response to the sustained chemical environment the body is living inside. Researchers who study this call it the conserved transcriptional response to adversity. It's not a poetic name. It was never meant to be. What it describes is a pattern found across many studies in many different kinds of human stress and loss, where certain genes associated with inflammation become more active and certain genes associated with antiviral defense become less so. The immune system doesn't simply ramp up or ramp down, it reorganizes. It changes what it's doing with its resources, quietly without asking. The result over weeks is a body that is slightly more inflamed at baseline and slightly less prepared for viral threat than it was before the loss. Neither of these changes announces itself. Neither generates a symptom you'd notice on an ordinary Tuesday. There is something, and this is just a personal noticing, not a conclusion, almost dignified about how small this all is. Not small in importance, small in scale. A cell is roughly 10 micrometers across. A micrometer is 1/1,000,000th of a meter. The changes happening in grief, the shifts in gene expression, the altered protein production, the slow reorganization of immune priorities are occurring at that scale, below that scale, in the movements of molecules that would need to be magnified tens of thousands of times before they became visible to any instrument a person could hold. And yet, they accumulate into exhaustion, into vulnerability, into a body that catches colds more easily in the months after a loss, that heals from minor injury a little more slowly, that runs a little hotter internally than it did before. The microscopic is doing enormous work. It just refuses to look like it. Outside there might be a smell of something and rain on warm pavement, or someone cooking late, carrying through a window left open an inch. The kind of thing that has nothing to do with anything, just the world continuing. The mitochondria are still running. This feels important to say, though it's hard to explain exactly why. Inside every cell undergoing this quiet reorganization, the mitochondria, the structures responsible for producing the cell's energy, are still working. Still converting nutrients into adenosine triphosphate, the molecule that powers nearly every biological process your body performs. The machinery of life is not interrupted by grief. It doesn't pause. It doesn't slow in any way that would register against its own continuous hum. What changes is how that energy is allocated. Inflammation is expensive. Mounting and sustaining an immune response, even a low-grade baseline shifted one, costs energy. Cellular resources that might otherwise go toward maintenance and repair are redirected, not dramatically, not in a way that depletes anything critical, just differently. A quiet rebudgeting, the body deciding without deciding that something else matters more right now. There's something we still don't fully understand about why this pattern persists. In acute stress, a sudden fright, a short-term physical threat, the immune and hormonal changes resolve relatively quickly once the stressor passes. The body returns to baseline, the gene expression shifts back, the inflammation settles. But grief doesn't pass the way a fright passes. It doesn't have a clear endpoint the body can recognize. The chemical signal, the elevated cortisol, the altered autonomic tone, the disrupted sleep architecture, keeps arriving day after day, week after week. And the cells keep responding to that signal as if the emergency is ongoing. Because in a sense, it is. The loss is not resolved. The attachment system is still searching. The nervous system is still cycling. And at the cellular level, the gene expression pattern that corresponds to sustained adversity keeps running, keeps reorganizing, keeps redirecting resources toward a response that cannot find its conclusion. It's not damage exactly. This is where language starts to feel inadequate. These changes, the altered gene expression, the shifted immune priorities, the mitochondrial reallocation, are not injuries. They are adaptations, the body doing what it was shaped to do across millions of years of living in a world where loss and threat were often the same thing, where the aftermath of losing a member of a group meant genuine physical danger, where sustained immune readiness in the wake of grief was not an overreaction, but a reasonable biological bet. The cells are not malfunctioning. They are following instructions that made sense for a very long time. What has changed is the world around those instructions, not the instructions themselves. And so the quiet continues. Cells dividing on their usual schedule, roughly, imperfectly, as they always have. Proteins being assembled and disassembled. Inflammatory signals rising and falling in slow, unmeasurable tides. Gene expression shifting by degrees so fine that no sensation corresponds to them. No feeling maps cleanly onto what is being reorganized in the dark. You're not aware of any of this. That is not a failure of attention. That is simply how it works. The cellular layer of grief running its own separate account, making its own adjustments, operating on a time scale and at a scale so removed from conscious experience that the two rarely meet. They meet eventually, in the fatigue that arrives without reason, in the cold that lingers a week longer than it should, in the low, unnameable heaviness that sits in the body on mornings when nothing specific has gone wrong. The cells were there first. They will be adjusting carefully, quietly, long after the mind has begun to find its footing again. You already know this feeling, not from reading about it, from inside it, that specific, strange moment of forgetting. The seconds after waking when the loss hasn't arrived yet, when the mind is still in whatever unguarded place sleep left it, and the person is simply present, expected, part of the texture of the world in the way they always were, and then memory returns, and the body does something involuntary, something in the chest or the throat or the sudden quality of stillness that descends, not because the grief is new, because the brain for a few unguarded seconds had stopped performing it and now has to begin again. This is not a glitch. This is not the mind being cruel to itself. This is a neural system doing exactly what it was built to do, with information it has not yet been able to update. There is a region of the brain, a collection of regions really, loosely networked, that tracks the people you are attached to. It doesn't work like a contact list. It works more like a map, constantly maintained, constantly updated with information about where attachment figures are, whether they are near or far, accessible or unreachable, safe or threatened. This circuitry involves parts of the prefrontal cortex, the anterior cingulate, structures deep in the limbic system that process social and emotional salience, and it is ancient. Far older than language, far older than the capacity to understand death as a concept. It evolved to solve a specific problem, keeping you close to the people your survival depended on. For most of human evolutionary history, that problem had physical solutions. Someone is too far away. The system generates distress, motivates approach, drives reunion. Someone returns. The system generates relief, releases oxytocin, rewards proximity with a feeling that is genuinely, measurably pleasurable. The loop closes. The search ends. The system was never given instructions for permanent absence. It was never told what to do when the person is gone, not because they wandered too far, but because they are simply gone. No location, no possibility of reunion, no closure the body knows how to generate, and so it keeps searching. This is the part that is hard to sit with, but important. The brain's attachment circuitry does not receive a notification. There is no biological mechanism by which the fact of death, understood intellectually, processed linguistically, accepted consciously, gets transmitted directly to the subcortical systems that are still, underneath all of that understanding, generating a search. The prefrontal cortex knows. The narrative-making parts of the brain know. But the older systems, the ones running the attachment map tracking proximity, generating the low pull of longing, these receive their information differently. They update through experience, through repeated exposure to absence, through the slow accumulation of moments where the search goes out and nothing returns. That updating takes time, months often, sometimes longer. Not because the person grieving is failing to accept the loss, but because the neural architecture of attachment was not designed for a rapid revision. It was designed for stability, for holding on, for continuing to search even when reunion seems unlikely, because in the environment it evolved for, persistence was usually rewarded. The smell of something, wood smoke maybe, from somewhere outside, moves through the room, irrelevant, present. What generates the longing is worth understanding, because longing in grief is often mistaken for something purely emotional, a feeling that exists in some vague psychological space, unmoored from biology. It isn't. The mesolimbic dopamine system, the same circuitry involved in motivation, reward seeking, the drive to pursue things the brain has tagged as valuable, is active in grief. Studies using neuroimaging have shown that when bereaved individuals are shown photographs of the person they lost, regions associated with reward and craving activate alongside regions associated with pain. The brain is not simply registering sadness, it is generating wanting, a genuine dopaminergically driven motivation toward reunion with someone the conscious mind knows cannot be reached. This is why grief can feel, at its sharpest, less like sadness and more like hunger, not metaphorically. The same circuitry, the same ancient drive, pointed at an absence it cannot stop treating as a destination. There are moments when this becomes briefly, terribly clear. Reaching for a phone to send a message, starting a sentence, out loud or only in the mind, that was meant for someone specific. Buying something and thinking, almost completing the thought that you should tell, and then the thought stops. Not because the mind corrected itself, because it ran out of road. These moments are not signs of confusion or denial. They are the attachment system mid-search, sending out a signal that returns no response, encountering the absence again as if for the first time. The system is not broken. It is doing what it always did, reaching, orienting, preparing for connection. The reaching just has nowhere to land now. Some researchers frame this as an extension of protest behavior, a concept from attachment theory describing the distress response that occurs when an attachment figure becomes inaccessible. In infants, protest behavior is visible, crying, calling, searching the environment. In adults, it becomes internal, quieter, often invisible from the outside. But the biology underneath is continuous with that early ancient response. The brain produces the signal, the body responds to it. And somewhere in the gap between the signal and its impossible resolution, what we call grief lives, not as a feeling exactly, but as a process. A biological search running on a system that hasn't yet learned at every level that the search is over. I find myself, and I say this carefully without certainty, thinking that there's something almost faithful about it. The circuitry refusing to update too quickly, holding the attachment open longer than the conscious mind might prefer, as if the brain at some level below thought is not yet willing to close the file. The anterior cingulate cortex processes something that researchers have called social pain. This is not a metaphor. When social pain is studied in neuroimaging, rejection, exclusion, the specific ache of loss, the anterior cingulate activates in patterns that overlap meaningfully with the activation seen in physical pain. The overlap is not perfect, but it is real. Real enough that in some early studies, low doses of acetaminophen were found to slightly reduce the felt intensity of social pain. a finding strange enough that it was initially difficult to publish. The pain of grief, the ache that sits in the body without a clear location, that feels physical without having a physical cause. This is not the mind dramatizing an emotional event. It is a genuine nociceptive adjacent response generated by circuitry that does not cleanly distinguish between a wound in the body and a wound in the attachment system. The body hurts because the body was built to hurt when connection is severed. That's not poetic framing. That's the anterior singularity doing its job in a situation it was built for. And underneath all of it, the search continues. Not loudly, not constantly after the first terrible weeks. But it doesn't stop. It becomes quieter, more intermittent. The moments of reaching grow less frequent. The automatic expectations slowly, very slowly begin to adjust. The attachment map updates, one experience of absence at a time, gradually revising its model of the world to include the shape of this loss. But it takes the time it takes, and the system cannot be hurried. What feels like being stuck in grief is often just this: the neural architecture of attachment doing its revision work at the only pace it knows. Careful, stubborn, faithful in its wow to the person it is learning to stop expecting. The search doesn't end all at once. It becomes over time a search that knows it won't find anything, and gradually in that knowing transforms into something else, something quieter, something that might eventually be called memory rather than longing. But not yet, not tonight. The body has made a decision, not consciously, not through anything resembling deliberation, but somewhere in the chemical conversation happening between your nervous system and your immune system, a conversation that began within hours of the loss, a decision was reached. Something is wrong, resources must move. The immune system does not deal in narrative. It doesn't receive the story of what happened, doesn't weigh the circumstances, doesn't distinguish between a wound you can see and one you can't. It reads the chemical environment it's living inside, cortisol concentrations, autonomic signaling, the particular molecular texture of sustained stress, and it responds to what that environment is telling it. And what the environment of grief tells it consistently is this: the body is under threat, sustained, ongoing, unresolved threat, so it responds accordingly. Pro-inflammatory cytokines are small proteins, signaling molecules. Their job ordinarily is coordination, alerting immune cells to the presence of injury or infection, recruiting the right responders to the right location, calibrating the intensity of the response to the scale of the problem. In grief, they rise without a clear target. Interleukin 6, interleukin-1 beta, tumor necrosis factor alpha. These aren't dramatic names for dramatic events. They're just the molecules the immune system uses to talk to itself, and in the weeks following significant loss, their baseline concentrations shift upward, not to the levels seen in active infection, not enough to generate fever or obvious inflammation, just higher. A low, sustained hum of immune activation running in the background of every ordinary day. You wouldn't feel it as inflammation. You'd feel it as heaviness, as a body that takes longer to get going in the morning, as a tiredness that sleep doesn't fully touch. There's a draft from somewhere, under a door maybe, or through a window frame that doesn't quite seal, carrying something cold and faintly damp. The body notices it before the mind does. It always does. What the immune system is doing here is expensive. Sustained cytokine elevation costs energy. Maintaining heightened immune surveillance, keeping more cells in circulation, keeping inflammatory pathways primed, requires continuous metabolic investment. The body is running a security response for a threat it cannot locate, cannot confront, cannot resolve through any action available to it. This is, from a purely biological accounting standpoint, an enormous amount of work for no return. But the system doesn't evaluate return, it only reads the signal, and the signal, the cortisol, the disrupted sleep, the altered autonomic tone, the continuous stress axis activation, keeps saying not safe yet, keep going, so it keeps going. There is something researchers have found in bereaved populations that still feels, to me, not fully settled, which is that the immune changes in grief don't affect all functions equally. Inflammatory activity rises, yes, but natural killer cell activity, the immune system's capacity to identify and destroy virus-infected cells and certain tumor cells, tends to decline. Antibody responses to vaccination are sometimes blunted. The immune system, under sustained grief stress, doesn't simply amplify everything. It reorganizes, shifts resources from some functions toward others. The result is a body that is simultaneously more inflamed and less defended. That asymmetry is strange to sit with, more active in a sense, more costly to run, and yet more vulnerable in specific measurable ways. It's not dysfunction, it's a response pattern, shaped over evolutionary time with conditions resembling grief, loss, separation, group disruption, genuinely correlated with increased physical threat. The inflammation was preparation. The immune reorganization was once a reasonable bet. It just doesn't map cleanly onto this kind of loss, this kind of world. The fatigue that arrives in grief, the specific heavy, reasonless exhaustion that sits differently from ordinary tiredness, is partly this, not entirely. Sleep disruption contributes, cortisol dysregulation contributes, the continuous low-level activation of the stress axis contributes, but the immune activity is part of it. The body is doing real work, expensive, continuous, invisible work. Synthesizing proteins, maintaining surveillance, staining an inflammatory response that has no endpoint it can recognize. The tiredness is not weakness. It is not depression masquerading as physical sensation, though those things can coexist. It is evidence, quiet, unannounced, of a system working as hard as it knows how to work, in response to something real, toward a resolution it cannot find. The exhaustion means something is happening. It just isn't happening anywhere you can see. There is a concept in psychoneuroimmunology, the field that studies exactly these intersections between psychological state and immune function, called the stress-immune interface. It describes in broad terms the bidirectional relationship between the brain's stress systems and the immune system's behavior. Stress changes immune function, and immune system activity, in turn, sends signals back to the brain. Cytokines crossing the blood-brain barrier, influencing mood, motivation, appetite, the felt sense of energy available for engaging with the world. This second direction matters. The immune system is not simply responding to grief. It is, in a very real biological sense, contributing to it. The cytokines circulating at elevated levels feed back into the brain and generate what researchers call sickness behavior. Fatigue, social withdrawal, reduced appetite, a dampening of motivation and pleasure that looks from the outside and feels from the inside remarkably like the effective texture of grief itself. The immune system didn't cause the grief, but it is helping to sustain the particular felt quality of it, the flatness, the heaviness, the sense that ordinary things require more effort than they used to. It is worth knowing this, not because it changes anything immediately, not because understanding the cytokine contribution to grief fatigue makes the fatigue lift, but because there is something clarifying about knowing that the heaviness has a source, that it is being generated, that somewhere beneath conscious experience, a very busy, very serious biological process is running, synthesizing, signaling, spending resources, doing its level best to respond to something it has categorized, incorrectly but not irrationally, as a threat to the body's survival. The immune system interpreted the loss as danger. It was wrong about the kind. It was not wrong that something real had happened, something that warranted a response, something that changed the body's relationship to the world in ways that would take time, biological time, not calendar time, to fully work through. The response is running. It will run for as long as the signal tells it to. And when the signal finally begins to quiet, the cortisol settling, the autonomic cycling slowing, the sleep architecture gradually returning toward its prior shape, the immune system will begin, without announcement, to stand down. Not all at once, slowly, the way everything in the body changes, in increments too small to feel, across days you won't be able to identify afterward, toward a baseline that will be close to what it was, close but not identical. The body that comes through grief is not the same body that entered it. That's not damage. That's just what it means to have been changed by something real. Sleep changes, not dramatically, not all at once, but in the days and weeks following significant loss, the architecture of sleep shifts in ways that are measurable, specific, and quietly strange. The change doesn't feel like a change from the inside. It feels like sleep that doesn't work the way sleep is supposed to work. Like waking at 3 a.m. for no reason you can name. Like dreams that leave a residue. Like mornings that arrive too early and too heavy, carrying something from the night that hasn't finished yet. What is actually happening underneath all of that is that the brain is attempting something difficult. Sleep in ordinary life is not a pause. This is worth saying plainly before anything else. During sleep, particularly during REM sleep, the stage characterized by rapid eye movement, vivid dreaming, and a distinctive pattern of brain activity that resembles, in some measurements, the activity of waking. The brain is doing specific, costly, important work. Consolidating memories, regulating emotion, processing the day's experiences through a series of neural rehearsals that gradually integrate new information into existing frameworks. It is, in this sense, less like rest and more like a second shift. A different kind of labour, running in the dark, using the absence of sensory input to do things that are harder to do while the world keeps arriving. In grief, this second shift gets heavier. REM sleep arrives earlier in the night than it used to. This is one of the more consistent findings in sleep research on bereavement. REM latency decreases, meaning the first REM episode begins sooner after sleep onset and tends to be longer than usual. The brain moves toward its emotional processing work faster, as if it knows, at some level below intention, that there is more to process than usual and less certainty about how long sleep will last. What happens inside REM is still not entirely understood. There are competing frameworks, ongoing debates, findings that don't fully reconcile with each other, but one model, developed by Matthew Walker and others, proposes that REM sleep provides a unique neurochemical environment for emotional memory processing. During REM, norepinephrine, one of the stress-related neurochemicals active during waking grief, is almost entirely suppressed. The brain reactivates emotional memories in this low norepinephrine state, allowing the emotional charge associated with those memories to be processed at a kind of remove. The memory returns, the feeling attached to it returns, but in a chemical environment slightly different from the one in which the experience originally occurred. The idea, and it remains partly theoretical, worth holding carefully, is that this allows the emotional weight of the memory to be gradually separated from the memory itself, that each REM reactivation strips a little of the raw charge away, leaving the factual content of the memory increasingly intact while the visceral, destabilizing feeling attached to it slowly softens. Grief interrupts this, not by preventing REM sleep entirely, but by disrupting its quality, its continuity, the specific neurochemical conditions it requires to do its work properly. Cortisol, elevated throughout early grief, often spiking in the early morning hours as the HPA axis begins its daily activation cycle, fragments sleep. It pulls the brain toward lighter stages, generate microarousals, shortens the deep slow wave sleep that precedes and supports REM. The REM that does occur arrives in a neurochemical environment that is not quite clean. Norepinephrine suppression is incomplete when the stress axis is running hot, which means the brain is attempting its emotional processing work under conditions that aren't fully optimal for it. The memory of the loss keeps returning in REM. The processing attempt keeps occurring. But the conditions for completing that processing are compromised by the same biological state that made the processing necessary. The brain is trying to do something it needs sleep to do, and grief is making sleep harder to sustain. Somewhere outside Sepki, or maybe inside, it's hard to place. There is the sound of rain beginning, not a storm, just rain, arriving quietly, the way it does when no one was watching the sky. The kind of sound that would ordinarily be enough to pull someone towards sleep. Tonight, it just sits there, doing its soft work against the window. Dreams change too. This is something bereaved people often report, and it is consistent enough across cultures and circumstances to be worth taking seriously as a biological phenomenon rather than a personal one. Dreams in grief tend to contain the person who's been lost, sometimes clearly, sometimes peripherally, sometimes in forms that aren't quite right, the face not quite matching, the behavior slightly off, the context strange in ways that don't become apparent until waking. Why the dreaming brain generates these images is not fully settled. One possibility, consistent with the emotional memory processing framework, is that the brain is using the REM state to rehearse the loss, to reactivate the neural representations of the person across different contexts, different emotional registers, different versions of encounter and absence. Not to resolve the grief, but to work it the way you might work a stiff joint, not to fix it, but to keep it from seizing entirely. Another possibility is simpler and less theoretical. The person who has been lost is one of the most activated neural representations in the grieving brain. Their face, their voice, the sensory and emotional signatures of their presence, these are among the most frequently reactivated patterns in waking experience. It would be strange if they didn't appear in dreams. The dreaming brain works with what it has, and what the grieving brain has in abundance is the neural echo of someone specific. There is something I find difficult to fully articulate about this. The idea that the brain keeps generating the person, keeps producing their image, their voice, the felt sense of their presence across waking and sleeping both. That the neural representation of someone you loved is, in a very literal sense, a pattern of activity your brain knows how to run, and keeps running in dreams, in flashes of memory, in the involuntary moments of imagining what they would say about something, because that pattern is still there, still active, still part of the brain's working model of the world. The dreams are not visitations, they are not messages, they are the brain doing what brains do, activating patterns, processing experience, attempting night after night to integrate something that doesn't integrate easily. And maybe that's enough. Maybe it doesn't need to be more than that to matter. The sleep disruption in grief has a shape. It tends to be worst in the early weeks, when cortisol dysregulation is most pronounced and the nervous system is still cycling through its most active protest response. It often involves early morning waking, the cortisol peak arriving too early, pulling the brain toward consciousness in the hours before light. It involves dreams that feel too vivid, too close, too saturated with feeling to leave cleanly when waking comes. And then, gradually, not on any predictable schedule, not in a way that can be forced or hurried, it begins to shift back. Slow-wave sleep returns toward normal depth. REM timing recalibrates. The cortisol peak moves back to its usual hour. Dreams involving the person who is lost begin to change in quality. Researchers have noted that over time, grief dreams often shift from distressing or disorienting to something more neutral, sometimes even comforting. The brain's representation of the person softens, perhaps from raw absence to something more like memory, still present, still activated, but carrying less of the acute emotional charge that made the early dreams so hard to wake from. Sleep is where a significant portion of grief's biological work happens, not all of it, not even most of it. But the REM processing, the memory consolidation, the slow emotional regulation that occurs when norepinephrine drops and the brain can work with its emotional content at a slight remove, this is real work with real neurobiological mechanisms that the body is attempting every night, regardless of whether sleep feels restful. The nights that feel wasted, that feel like hours spent not sleeping, or sleeping badly, or waking from dreams too heavy to carry back into the day, these are not wasted. The brain was working. In the disrupted, incomplete, chemically compromised way that grief makes inevitable, but working. The way someone works when the conditions aren't right and the task is too large and the tools aren't quite adequate and they keep going anyway because the work needs doing and there is no one else to do it. Sleep keeps trying, even here, even now, with everything slightly wrong, the architecture altered, the chemistry imperfect, the dreams too full of someone who is no longer in the world. The brain keeps showing up for its second shift, attempting in the dark and quiet what waking cannot finish. The body learned someone, not their name, not their history, not any of the things the mind holds about a person, the stories, the particular way they laughed, the opinions they had about small things. What the body learned was different, simpler, more physical, how to be near them. This learning happened gradually, over the time the relationship existed, through thousands of ordinary moments of proximity, sitting beside them, standing in the same kitchen, sleeping in a bed calibrated to two bodies rather than one. The nervous system, which is continuously collecting data about the sensory environment, was taking note of all of it. The specific sound of their breathing in a quiet room, the way your own posture shifted slightly when they walked in, the particular relaxation that happened in the muscles of the shoulders and jaw when their presence registered as safe. This is not a poetic description of love. This is a literal biological process, the nervous system updating its model of the environment to include a specific person as a recurring, predictable, safety-relevant feature of that environment. The body didn't just know them emotionally, it knew them spatially, physically in the tissue. Posture changes in the presence of attachment figures. This is measurable. When people who feel securely attached are in proximity to someone they love, muscle tension decreases in specific regions. The trapezius, the muscles running along the back of the neck, the small muscles around the jaw that hold more tension than most people realize they carry. The parasympathetic nervous system becomes more active. Heart rate variability increases, reflecting a more flexible, less defended autonomic state. Breathing deepens without any decision to breathe more deeply. The body, in the presence of someone it has learned to trust, physically relaxes in ways it doesn't fully relax otherwise. Over time, that relaxation becomes anticipated. The nervous system, which is always predicting, always running models of what is likely to happen next based on what has happened before, begins to generate the anticipatory state before the person actually arrives. The sound of a particular footstep on a stair, a key in a lock, a specific quality of the air in the house when someone else is also in it. The body starts to prepare for the relaxation before the cause of that relaxation appears. Outside, a car passes slowly, its headlights moving across a ceiling somewhere in the dark. Then nothing. The particular quality of abundance that follows feels different from the students before.
When the person is gone, that anticipation doesn't stop immediately. This is the part that catches people off guard. Not the sadness which they expected, but the physical wrongness of ordinary moments. The reaching for a space in the bed that is colder than it should be. The slight automatic shift of posture toward a door when a sound occurs at the time they used to arrive. The way the body prepares briefly for a presence that doesn't come. These aren't hallucinations. They aren't confusion or denial. They are the nervous system running a prediction that is no longer accurate, a model of the environment built over months or years of consistent data, still generating its outputs, still preparing the body for an experience that the conscious mind knows will not occur. The prediction fires, finds nothing, and the body registers that gap, not as a thought, not as a feeling exactly, but as a specific physical incorrectness. A bracing that had somewhere to land before and now doesn't. A relaxation that was cued and never arrived. The proprioceptive system, the network of sensors in muscles, tendons, and joints that gives the brain continuous information about the body's position in space, was part of this calibration too. Shared physical space with another person, over time produces subtle but real changes in how the body occupies that space. Couples who sleep together develop sleep positions that account for another body. People who spend significant time with someone they love develop habitual orientations toward them, the unconscious tendency to angle slightly in their direction, to maintain a certain distance that feels comfortable, to reach into the space they usually occupy. These physical habits live in the body below conscious awareness. They were never learned deliberately. They accumulated through repetition, through the nervous system's continuous low-level optimization of how to be near this specific person in this specific way. They don't unlearn quickly. There is something about this that I notice but find hard to place. The way grief is sometimes most acute not in the large emotional moments but in these small physical ones. The posture that prepared for someone who didn't come. The hand that moved toward the space and found it empty. The particular quality of lying down in a bed that was calibrated for a long time to two people. These moments aren't dramatic. They're just the body, mid-prediction, running an old program in a world that has changed around it. The somatosensory cortex maintains representations of other people, not just yourself. The brain maps your own body continuously, maintaining a kind of running model of your physical form and its position in space. But it also, through the experience of touch and physical proximity, builds representations of the bodies of people you are close to. The specific weight of someone's hand, the particular temperature of their skin, the way their breathing felt when you were close enough to feel it. These representations don't disappear when the person does. They remain encoded in the tissue of the nervous system, ready to be activated by something close enough to what they remember, a texture, a temperature, a particular quality of warmth in a specific place. This is part of why being held by someone in grief, can feel both comforting and unbearably wrong simultaneously. The comfort is real. Touch activates oxytocin, reduces cortisol, engages the parasympathetic system. But the somatosensory representation knows the difference, knows the weight is wrong, the temperature slightly off, the particular way of being held not quite matching what the system learned to expect, close, but not the same. And the nervous system, which is precise in its record keeping, notices. Slowly, across months, not weeks, this changes. The predictions become less frequent, the automatic postural preparations fire less often. The somatosensory expectations of a specific person's presence gradually lose their hair trigger readiness, their constant low-level anticipation. Not because they are erased. The nervous system doesn't erase things easily, but because the world keeps arriving without confirming them. Each time the prediction fires and finds nothing, the neural model updates very slightly. The expectation recalibrates fractionally toward a world that doesn't include that presence in the same way. The body learns the absence the same way it learned the presence, slowly through repetition, through the accumulation of ordinary moments that contain a slightly different reality than the one it was holding. It takes as long as it takes. The body was thorough in its learning. It will be equally thorough in its revision. And somewhere in the gap between those two, between the learning and the revision, between the prediction and the absence it keeps finding, is where the muscle memory of another person lives, still running, still expecting, still somewhere in the tissue, waiting for a presence that knew how to make it quiet. Cortisol has no feeling. This is the first strange thing about it, that a hormone capable of reorganizing nearly every major system in the body, of altering memory consolidation and immune function and cardiovascular rhythm, and the way the gut moves and the way the brain processes threat, produces no direct sensation. No signal arrives in consciousness that says this chemical is elevated, no internal alarm, no proprioceptive register of something shifting in the blood. It simply changes what the body does, quietly, continuously. In the background of every ordinary moment, adjusting the parameters of biological function in ways that accumulate over days and weeks into something the body can feel. But by the time the feeling arrives, the cause is invisible, already dissolved into the ongoing chemistry of a system that has been running differently for longer than it's easy to track. The hypothalamic pituitary adrenal axis, the HPA axis, is the system responsible for cortisol production. It works like a slow conversation between three structures: the hypothalamus, which detects disruption and sends a signal, the pituitary gland, which receives that signal and broadcasts a hormone of its own, and the adrenal glands sitting above the kidneys, which respond to the pituitary's broadcast by releasing cortisol into circulation. Under ordinary conditions, this conversation is brief and self-correcting. A stressor arrives, cortisol rises, and then a feedback mechanism detects the elevated cortisol and signals the hypothalamus to quiet down. The system resets, baseline resumes. In sustained grief, the feedback mechanism struggles. Not because it breaks, nothing breaks exactly, but because the signal that drives the axis, the disruption, the threat detection, the continuous low-level activation of the stress response, doesn't resolve. The stressor is not an event with an endpoint. It is a condition, a changed state of the world that the brain encounters not once but continuously, every morning when consciousness returns, in every ordinary moment that used to be ordinary in a different way. The HPA axis keeps receiving the signal, and so it keeps producing cortisol. In the acute phase, the first days and weeks, cortisol elevation is pronounced. The body is in something adjacent to high alert, sleep is fragmented, appetite is disrupted, the immune system is reorganizing, the autonomic nervous system is cycling, everything is expensive, everything is running hot, and cortisol is part of what is fueling that expense, mobilizing glucose, keeping the brain in a heightened state of vigilance, ensuring that the body's resources are available for a crisis that has no physical form to respond to. This phase is exhausting in a way that is almost legible. The tiredness is total. The body is clearly doing something enormous, even if what it's doing has no visible output. Then the acute phase ends, or rather, it doesn't end cleanly, it transitions. The sharpest edge of the response begins to dull, sleep becomes slightly more possible, appetite returns in fragments, the autonomic cycling slows, and cortisol, which had been elevated dramatically, begins to lower, but not to baseline. This is the part that is easy to miss and harder to study, and I think, and I say this as someone who finds the research genuinely unsettled here, more important than the acute phase in terms of what grief actually does to the body over time. The sustained moderate cortisol elevation that persists in the months following significant loss, not the spike, the floor that has been raised. Somewhere, a blanket maybe, or a specific heaviness in the air of a room at night, has a particular weight to it tonight, dense. The kind of heaviness that makes it harder to remember what lightness felt like. What does a raised cortisol floor actually do over months? The effects are distributed across nearly every system, and because they are gradual and invisible and have no direct sensation, they tend to be attributed to other things. To grief itself as a psychological state, to depression, to aging, to ordinary variation in how the body feels from week to week. Memory consolidation changes. Cortisol at sustained elevated levels affects the hippocampus, the structure most associated with the formation and retrieval of explicit memory, in ways that make new learning slightly less efficient. Not dramatically, not in a way that would show up on a standard cognitive test in most people, but in the quiet, private experience of feeling like the mind is less sharp than it used to be, that names and words and recent events are slightly harder to hold, that concentration requires more effort than it should. The cardiovascular system reorganizes around the new hormonal baseline. Blood pressure tends to run slightly higher. Arterial flexibility, the capacity of blood vessels to dilate and contract responsively, decreases incrementally. The heart, which under normal conditions is a remarkably adaptive organ, finds itself working inside a sustained chemical environment that asks it to maintain a slightly higher state of readiness than its ordinary resting function requires. Muscle tissue becomes subtly more vulnerable to breakdown. Bone density over longer periods of sustained cortisol elevation can be affected. Skin heals more slowly from minor damage. The gut's motility, the rhythmic muscular contractions that move things through the digestive tract, becomes irregular in ways that show up as appetite changes, digestive discomfort, a relationship with food that doesn't feel quite right. None of this is catastrophic. None of it, in most people experiencing grief, rises to the level of clinical illness. But it accumulates, quietly, in the body's background, in the difference between the person who entered grief and the person who is, months later, beginning to move through it, not damaged but changed, carrying a slightly different biological baseline than the one they arrived with. There is a concept called allostatic load. It describes the cumulative wear on the body that results from sustained stress response activation, the biological cost accumulated over time of a system that has been running at elevated levels for longer than its short-term design intended. Cortisol is a central contributor to allostatic load. The immune reorganization contributes, the cardiovascular changes contribute, the sleep disruption contributes. Each system running slightly differently, each deviation from baseline costing something, the total cost rising across weeks and months into a kind of biological debt that the body will eventually need to repay. This is not a dramatic concept. It doesn't produce dramatic symptoms. It produces a body that feels in ways that are hard to articulate, older than it did before. More worn at the edges, less resilient to small additional stressors. A minor illness hits harder, recovery takes longer. The nerves that used to absorb ordinary difficulty feel somehow thinner. This is where I find myself uncertain, not about the biology, which is reasonably well documented, but about what to do with this information. Knowing that grief elevates cortisol, that cortisol accumulates allostatic load, that the body carries the biological cost of loss in its chemistry and its tissue, knowing this doesn't change what the body is doing. It doesn't accelerate the normalization. It doesn't give the HPA axis a reason to quiet down sooner. What it might do, perhaps, is make the experience of the body in grief feel less like personal failure and more like physics. The fatigue is not weakness. The cognitive fog is not deterioration. The body feeling older, slower, more brittle than it used to feel, these are not signs that something is going wrong. They are signs that something real happened, something with genuine biological weight, something the body is carrying in the only way bodies know how to carry things, in their chemistry, in their tissue, in the slow and invisible reorganization of systems that have been asked to adapt to a world that changed without warning. Cortisol will normalize. Not on a fixed timeline, not predictably, but the research on bereaved individuals followed over longer periods consistently shows a gradual return toward baseline as the acute grief response softens, as sleep architecture improves, as the HPA feedback mechanism, which was never broken, only overridden by a signal that wouldn't quiet, begins to reassert its regulation. The cardiovascular markers improve. Immune function gradually restores its prior balance. The hippocampus, which is remarkably plastic and more resilient than it is often given credit for, begins to recover its ordinary consolidation efficiency. The body moves back toward itself, slowly, on biological time, not calendar time, in increments that won't be visible day to day, that may not even be visible month to month, but that accumulate the way the original disruption accumulated into a changed baseline. One that is close to what came before, close, but carrying quietly the evidence of what it has been through, not as damage, as history. Hunger is not a simple thing. It feels simple. That familiar pull, the hollow pressure somewhere behind the stomach, the way attention starts drifting toward food when the body needs it. But underneath that feeling is a continuous biological negotiation involving at least a dozen hormones, several brain regions, the enteric nervous system running through the gut, and a feedback loop between the stomach and the hypothalamus that has to complete itself correctly for the signal to arrive in consciousness at all. When grief disrupts this negotiation, it doesn't do it loudly, it garbles it. Ghrelin is produced in the stomach. Its job primarily is to signal hunger, to rise when the stomach is empty and the body needs fuel, to carry that signal upward through the bloodstream to the hypothalamus, which receives it and generates the felt experience of wanting to eat. Under ordinary conditions, this cycle runs reliably. The stomach empties, ghrelin rises, the hypothalamus responds, hunger arrives, food is eaten, ghrelin falls, the signal quiets. In acute grief, ghrelin dysregulation is common. The pattern isn't consistent across all people. Some experience elevated ghrelin and heightened hunger, particularly for calorie-dense food, which may reflect the stress axis's demand for additional energy. But many, perhaps most people in the early weeks, experience something closer to the opposite. A blunted ghrelin response, the stomach empties, the signal is produced, and somewhere between production and reception, something in the disrupted hormonal environment of grief interferes with the clarity of the message. The hunger doesn't arrive, or it arrives muffled, distant, easy to overlook, a suggestion rather than a demand, quiet enough to be ignored through an entire morning without noticing. Cortisol is partly responsible for this. Elevated cortisol suppresses appetite in the short term, an evolutionary logic that makes some sense since stopping to eat during an acute threat is not a survival priority. In the immediate aftermath of loss, when cortisol is at its highest, the appetite suppression can be total. Food becomes not just unappealing but genuinely absent from the field of desire, as though the brain has simply removed it from the list of things worth wanting. This is why people in acute grief sometimes go long periods, a full day, sometimes longer, without eating, not through discipline or forgetfulness, but because the biological signal that would normally make eating feel necessary simply isn't arriving. The body is running on its existing reserves, cortisol is keeping the urgency of hunger suppressed, and the conscious mind, occupied with something else entirely, doesn't notice the gap. Leptin complicates this further. Leptin is produced by fat cells and signals satiety to the hypothalamus, tells the brain that energy reserves are sufficient, that the urgency of hunger can be reduced. During sustained stress, leptin levels can become dysregulated in ways that send conflicting messages to the same hypothalamic circuits that ghrelin is trying to reach. The result is a system receiving simultaneous signals: eat, don't eat, you're full, you're empty, that don't resolve cleanly into a coherent felt experience of hunger or satisfaction. Add to this the fact that CRH, corticotropin-releasing hormone, one of the early signals in the HPA stress cascade, directly suppresses appetite at the hypothalamic level, and that the vagus nerve, which carries information from the gut to the brain and is already running in a disrupted state in grief, is also a primary pathway for hunger and satiety signals, and that the dopaminergic reward circuits that normally make eating pleasurable, that generate the anticipatory wanting of food, the satisfaction of eating something good, are the same circuits running the grief-related longing response, already occupied, already pointed elsewhere. The system that generates appetite is not broken. It is simply otherwise engaged, running in a context that has disrupted nearly every input it depends on simultaneously. There is something almost quiet about this kind of hunger loss, quieter than pain, quieter than the more visible expressions of grief. A person can move through an entire day looking, from the outside, completely functional and be running on almost nothing, not because they chose to fast, but because the signal that would have told them to eat never arrived with enough force to act on. The body doesn't complain exactly, it compensates, draws on glycogen stores, then begins to shift toward other energy sources. The metabolism adjusts as it always does to the available fuel. The brain, which has an enormous glucose requirement and gets priority in any shortage, continues to receive what it needs. But the rest of the body begins to notice, in the low-level way that biological systems notice resource shortfalls, that something is different. Outside somewhere, a light is on in a window across a street. Or perhaps it's the particular yellow quality of a lamp left burning in another room, something warm and entirely irrelevant, just present in the way ordinary things are present when everything else has changed. What makes this particularly strange is that the body doesn't always register the hunger it has missed. Normally, skipping a meal generates a compensatory increase in appetite. The body notices the deficit and amplifies the signal. In sustained grief, this compensation is often blunted. The hormonal disruption that suppressed the original signal also interferes with the catch-up mechanism. The body falls behind on fuel without generating the urgency that would normally drive correction. People in grief sometimes describe this as having lost their relationship with food entirely, not disliking it, not finding it unpleasant, but simply losing the thread of it. The body-mind conversation about eating that used to run automatically in the background has gone quiet, and without it, meals become things that happen when someone else suggests them, or when a clock indicates it is time, or simply not at all. There is something here, and I notice it without quite knowing what to do with it, about how thoroughly grief occupies the biological resources that ordinarily manage basic self-maintenance. The same hormonal terrain that regulates appetite also regulates sleep, immune function, cardiovascular rhythm, emotional regulation. Grief disrupts them all simultaneously, drawing on the body's adaptive systems from multiple directions at once. And appetite, perhaps because it lacks the urgency of pain, because its absence doesn't demand attention the way sleeplessness does, often falls quietly through the gaps. The body forgets to be hungry not because it doesn't need fuel, but because the system that communicates need is running through a landscape so disrupted that the message keeps getting lost somewhere between the stomach and the brain, between the signal and the place that was supposed to receive it. Appetite returns, not suddenly, not on any schedule the body announces in advance. But as the cortisol floor begins to lower, as the HPA axis gradually reasserts its feedback regulation, as sleep slowly improves and the autonomic nervous system reduces its cycling, the hormonal environment that garbled the hunger signal begins incrementally to clarify. Ghrelin finds its rhythm again, leptin signaling stabilizes. The vagal pathways between gut and brain resume their ordinary traffic. And hunger, which was always there as a biological need even when it wasn't arriving as a felt signal, begins to make itself known again. Sometimes this happens as a sudden surprising return, a moment when food smells like something again, when the body produces a genuine, unambiguous hunger that feels almost startling after weeks of its absence. Sometimes it is quieter than that, a small appetite, partial, uncertain, a signal that has found its way back through disrupted terrain, arriving not triumphant but tentative, testing gently whether the conversation between stomach and brain is open again, whether the body is ready finally to remember that it still needs to be fed. There are a few seconds, some mornings before grief arrives, not every morning, and not forever. But in the early weeks especially, there is sometimes a window, brief, unguarded, neurologically real, between the moment consciousness returns and the moment memory catches up with it. The brain surfaces from sleep still warm with whatever the night held, and for a few seconds the world is simply the world, and the person is simply present in it, and nothing has yet been lost. Then memory arrives, and the body does something involuntary, something in the chest or the throat or the quality of stillness that descends, that is not quite pain and not quite shock, but something older than both, something that has been waiting just outside consciousness for the moment when it could return. This moment is not a failure of acceptance. It is not the mind refusing to integrate what happened. It is the attachment system doing exactly what it was built to do, maintaining the representation of the person you loved in a state of active, ready, expected presence, and encountering again the information that that representation no longer corresponds to anything in the world. The collision happens every morning until gradually it doesn't. Oxytocin is sometimes described as the bonding hormone, which is accurate enough as a simplification but loses something important in the compression. What oxytocin actually does, across a broad range of social contexts in both humans and the mammals we share it with, is reduce the cost of proximity to specific individuals. It dampens the stress response in the presence of attachment figures. It increases the salience of social information. It makes the face of someone familiar feel, at a neurochemical level, like safety, like a signal that the threat detection systems can stand down, that the expensive vigilance of being a social animal moving through an uncertain world can briefly be suspended. Vasopressin works alongside it, particularly in the formation of long-term pair bonds, reinforcing the neural circuitry that makes a specific person feel irreplaceable rather than simply pleasant. Not just good to be near, necessary. The particular neurochemical fingerprint of this person, distinct from all others, encoded into the reward and threat systems simultaneously, wanted when present, missed when absent, searched for when gone. Together, these two neuropeptides built the architecture of your attachment, not metaphorically, literally, in the synaptic connections, in the receptor densities, in the specific neural pathways that activate when the person you loved walked into a room. Oxytocin and vasopressin were doing the molecular construction work, binding the attachment into the tissue of the nervous system over months and years of proximity, shared experience, the accumulated neurochemical reinforcement of someone who kept being there. They were never given instructions for what to do when the person stops being there. This is the thing that I keep returning to, and I'm aware it may not resolve into anything clean when thinking about why grief is the shape it is, why it has the particular biological texture of longing and searching and the morning seconds of forgetting. The oxytocin and vasopressin systems that built the attachment were optimized for building and maintaining it, not for releasing it, not for updating it, not for receiving the information that the person whose presence those systems have encoded as essential is no longer present and will not be again. There is no molecular mechanism for that update. The systems simply keep running, generating the wanting, activating the reward circuitry in anticipation of reunion, flagging the absence as a condition to be corrected, a problem to be solved, a disruption to be resolved by the action that historically resolved it, proximity, contact, the return of the person whose presence the nervous system was shaped over a long time to expect. The mesolimbic dopamine system, the circuitry that generates motivation, that drives approach behavior toward things the brain has tagged as valuable, is recruited into this. Neuroimaging studies of bereaved individuals have shown activation in reward-related brain regions when they are shown photographs of the person they lost. The same circuits that activate in hunger, in romantic longing, in the anticipation of something deeply wanted, these circuits activate in grief, not instead of pain, alongside it. The brain is simultaneously registering loss and generating craving, running a wanting response for something it cannot have, producing the neurochemical signature of motivation toward a destination that no longer exists. This is why grief can feel at its sharpest like something other than sadness, like incompleteness, like a question the body keeps asking that nothing can answer, like reaching continuously for something just outside reach, not because the person grieving is confused about what happened, but because the biological system doing the reaching has not received, at every level it operates, the information that the reaching is over. The cortex knows. The attachment system keeps reaching. The light through a curtain, or the particular darkness before any light arrives, carries a specific quality in the early morning that has no name. The kind of thing that exists in the room before anything else does, before memory, before the weight of the day settles back into place. Attachment theory, as developed by John Bowlby and extended by researchers across the following decades, proposes that the behaviors seen in grief, the searching, the longing, the protest and despair, and gradual reorganization, are not pathological responses to loss, but the normal operation of an attachment behavioral system encountering a situation it was not designed for. Bowlby drew a direct line between the grief responses observed in bereaved adults and the separation distress observed in young children when attachment figures become inaccessible. The phenomenology is different. Adults grieve differently than children protest separation, but the underlying biology is continuous, the same ancient system, the same fundamental architecture of attachment and loss, running in a more complex nervous system but drawing on the same evolutionary substrate. What this means in practice is that the longing in grief is not a symptom, it is the attachment system working faithfully, persistently in the only direction it knows, toward reunion, toward the restoration of proximity with the person it has encoded as essential in a situation where that reunion is permanently impossible. The faithfulness is not a comfort, exactly, but it is, I think, worth knowing. That the biology of grief is not malfunction, that the reaching and the searching and the morning seconds of forgetting and then remembering, these are not signs that something has gone wrong in the nervous system. They are signs that the attachment system is doing its job with complete biological fidelity in conditions it was never, evolution did not model death. Not in the sense of preparing the attachment system to respond adaptively to permanent loss. For most of the evolutionary history during which these systems were being shaped, the relevant experiences were separation and reunion, temporary inaccessibility, not permanent absence. The attachment behavioral system was optimized to respond to the former, to generate distress that motivated search, to sustain that search through considerable difficulty, because in the environment the system evolved for, persistence was usually rewarded. Permanent loss was relatively rare, or at least rare enough for most of that history, that there was no particular evolutionary pressure to develop a mechanism for cleanly shutting the system down when reunion was genuinely impossible. And so no such mechanism exists. The attachment system runs until the neural model of the world gradually, experientially updates, not through a single update event, not through conscious decision, but through the slow accumulation of moments in which the search goes out and nothing comes back. Each absence registered, each morning of remembering added to the count, each reaching that finds only empty space, incrementally revising the prediction, fractionally adjusting the model, until the system that was built for reunion has been remade across months of unanswered reaching into something that can hold the loss without continuously generating the search. This is not closure. Closure implies a mechanism, a switch, a biological event that ends the process. There is no switch. There is only the slow, faithful, effortful work of a nervous system revising its model of the world one absence at a time, across a timeline determined not by the mind's readiness but by the pace at which neural architecture actually changes, which is slower than anyone wants and more thorough than anyone expects, and which ends not with the attachment being erased but with it being held differently, still there, still encoded in the oxytocin pathways, the vasopressin circuitry, the reward system's memory of what it felt like when the person walked into a room, just quieter now, carried rather than chased. And on some mornings, not all mornings, not forever, there are still a few seconds before grief arrives, the brain surfacing from sleep, the world simply being the world, the person still present in whatever unguarded place the night holds them. Then memory returns, and the chest does its involuntary thing, and the attachment system, faithful as ever, registers the absence it will spend the rest of this long biology learning slowly to hold. The biology doesn't stop when the chapter ends. This is the thing that's hardest to hold, and maybe the most important, that the processes described across this long night are not stages that complete themselves and step aside. They are systems, continuous, overlapping, running on their own timescales, indifferent to the calendar, indifferent to how ready the conscious mind is for them to be finished. The immune response is still making its slow adjustments. The HPA axis is still negotiating its return toward baseline. The attachment circuitry is still somewhere in the neural architecture of the brain, maintaining a representation of the person who is gone, quieter now perhaps, less insistent, but present, still encoded, still part of the model. The body does not file grief away. It carries it forward, changed by it, in the tissue and the chemistry and the particular way a nervous system that has been through something reorganizes itself around what remains. What remains is worth thinking about carefully without rushing toward either comfort or despair. The immune system, which mounted a response to a threat it could not locate, and sustained that response across weeks of elevated cytokines and reorganized cell populations, this system is, in most people, gradually returning toward its prior functional balance. The inflammatory tone is lowering. Natural killer cell activity is recovering. The gene expression patterns associated with sustained adversity are beginning, very slowly, to shift back. Not to exactly where they were, but close, and the closeness matters. The HPA axis, which has been running hot since the first hours after loss, producing cortisol at a raised floor, disrupting sleep and appetite and memory consolidation and cardiovascular rhythm, is beginning to reassert its feedback regulation. The cortisol is lowering. Not dramatically, not on any day you could point to, but across the accumulated weight of days, The baseline is descending towards something that resembles what it was before. The sleep architecture is returning, slow-wave sleep is deepening again. REM is arriving at its usual hour rather than rushing in too early, too full, too saturated with faces and feelings the waking mind isn't ready to carry. The dreams are changing, still present, still containing sometimes the person who was lost, but differently, less raw, less disorienting, more like memory and less like wound. And the attachment system. This one is slower than the others, more stubborn, more faithful to its own timeline, which is not the timeline of cortisol normalization or immune recovery or sleep architecture recalibration. It runs on a different kind of time, the time of neural revision, of experiential updating, of a model of the world changing not through decision, but through the slow accumulation of moments in which the world keeps being different from what the system expected. The morning seconds are still happening, perhaps, still that brief window between consciousness and memory, between the world as the nervous system holds it and the world as it is. The collision still arriving, the chest still doing its involuntary thing, but the window may be narrowing. The collision may be slightly softer than it was. Not because the attachment is diminishing, it isn't, not really, not in any fundamental sense, but because the neural model is updating one morning at a time, one unanswered reaching at a time, toward a version of the world that has learned to hold the absence without continuously generating the search. This is what the slow rewiring actually feels like from inside. Not healing, not moving on, more like somewhere, a sound. Something small and irrelevant, a pipe settling or the specific creak a house makes in the early hours when the temperature outside has dropped. The kind of sound that has nothing to do with anything, that is simply the world continuing the way it does. There is something I want to say here that I'm not sure I can say cleanly about what it means that the body went through all of this, that the immune system mobilized, that the cortisol rose and stayed risen, that the vagus nerve held something in the chest for weeks, that the attachment circuitry kept reaching into empty space, that the sleep architecture bent itself around the weight of the loss, that the cells quietly reorganized their gene expression in a pattern that researchers recognize across thousands of grieving bodies as the conserved biological signature of having loved someone and lost them.
All of that happened in real tissue, in actual chemistry, in the biology of a specific body that was changed, not destroyed, not broken, but genuinely, measurably, permanently changed by the experience of caring about another person enough that their absence produced this. The biology of grief is the biology of attachment, running past the point where attachment can be completed. That's all it is. And this channel exists because some nights the body needs something slower than the world usually offers, something that takes the questions that live below language, about what is happening inside, about why the body feels the way it feels, about whether any of this makes sense at a level deeper than emotion, and holds them in the kind of light that makes them easier to carry into sleep. If this has been that for you, tonight, or on any other night, if something in these long, quiet hours has landed somewhere useful, the quietest thing you can do, the thing that keeps this space alive and makes the next one possible, is to stay, to subscribe if you haven't, to leave something in the comments if a thought arrived that wants somewhere to go. The members who support this channel through membership and super thanks are, in a very real sense, the reason this biology gets to be spoken aloud into the dark at all. I don't take that lightly. I don't think I ever will. The body that arrived at the beginning of this night is not quite the same body that is here now, Not because of anything that happened in the listening, but because biology is continuous, because the immune adjustments and the cortisol shifts and the slow neural revision of the attachment system were already underway before this began, and they have continued through it, and they will continue after. The body is always in the middle of something, always partway through a process it didn't choose and cannot fully observe, always carrying in its chemistry and its tissue the accumulated evidence of everything it has been through. Grief leaves a residue, not damage, evidence, the biological record of having been changed by something real, by a love that was real, an attachment that was real, a loss that the nervous system is real enough to register in cytokines and cortisol, and the architecture of sleep and the stubborn faithfulness of circuits that were built to reach and have not yet fully learned to stop. This residue is not something to be cleared. It is something to be carried, differently over time, more quietly, with less of the acute biological cost that the early weeks demanded, but carried because the carrying is what it looks like from the inside when a nervous system has loved something enough to be changed by losing it. The immune system is still running. The HPA axis is still negotiating. The attachment circuitry is still holding, somewhere in its ancient and faithful architecture, the neural representation of a person who mattered enough to make the body go through all of this. And you, the specific body that has listened to all of this tonight, that is lying somewhere right now with its own particular history of love and loss and the slow biological work of carrying both, you're still running too, changed, still here, still in every cell and circuit and slowly normalizing chemical, doing the quiet, continuous, unhurried work of being a living thing that has been through something. That work doesn't stop tonight. It just gets to happen for a little while in the dark, while the body rests as much as it can, while the biology continues as it always does beneath the threshold of anything you need to be awake to manage. It knows what it's doing. It has always known, and it will keep knowing quietly and without your help through whatever hours remain until morning finds you again. A little further along, a little more revised, a little closer to the baseline that grief has been all this time slowly returning you to. Not the same baseline, never quite the same, but yours, still yours.